Hello students, greetings of the day. So today we'll talk about polarization. Fine.
See here, we have seen that light actually, depending on the situation, what nature, right? We are imbibing particle nature. Certain time we are imbibing what nature? Wave nature for the light. Okay. Depending on, like, for example, to explain the phenomenon of photoelectric effects, so we assume that light behaves like particle nature. That is photons, quantum of what radiation we have said. And to explain phenomena to certain phenomena to explain like interference, you can say diffraction, you can say. Okay, unless we imbibe what nature, wave nature for the light, we cannot explain the phenomena. Therefore, now you are depending on the situation. But of course, light you are accepting as a wave. In the beginning, Huygens thought that light is a mechanical wave, and he mentioned that it requires a medium for propagation. And he said that a particular medium is completely occupied the entire whole universe, okay, whose density is very, very less. And later, by Michelson Morley experiments that we study in higher classes, people, it is proved that ether doesn't exist, and light is not a mechanical wave. So by Maxwell's equation, electromagnetic wave theory, we have seen that light is electromagnetic wave in which vectors are oscillating here. Direction of propagation is like this here. For example, electric field vector will oscillate in one particular direction. Okay, magnetic field vector will oscillate perpendicular to this direction. Isn't it? So, and direction of propagation is like this. So, if I take this particular axis as x-axis, this particular axis as y-axis, this particular axis as z-axis. The direction of propagation is z. So, next direction electric field vector will oscillate perpendicular to x, y, and these two directions of oscillations of this electric as well as magnetic vectors are perpendicular to direction of c here. Direction of propagation of the vector. So, now here, these are saying that, okay, fine, electromagnetic waves are saying that actually light is a wave, okay, in which C is not a mechanical wave, medium not required. Then how it is propagating? By oscillating electric and magnetic fields. Okay, oscillating electric field generates magnetic field generates electric field, and mutually perpendicular they are oscillating, and perpendicular to these two directions light is propagating. So we accepted that light is what? Electromagnetic wave. Now next, so we can think that light like what? Now next question comes, okay, fine, it doesn't require medium, it is not a mechanical wave, it is electromagnetic wave. So what type of wave? That is longitudinal transverse in nature. So other phenomena like interference, diffraction, they could not tell about this nature. So only one particular phenomena, that is called what? Polarization. It explains that light is a transverse in nature. Light is what? Light waves are transverse in nature. So how light waves are transverse? What is the meaning of transverse waves? The waves in which, if you take mechanical waves, the waves in which, for example, if a wave is propagating like this, the direction of particles of this medium vibrate perpendicular direction of propagation. Perpendicular direction of propagation. This kind of waves, what we call? We call it as what? Transverse waves. So if direction of propagation of the particles of the medium is perpendicular to what? Direction of propagation, such kind of waves are called transverse waves. Now in this one, this medium is not at all there. Now how do you classify as transverse? This thing is that, so find direction of propagation of wave is like this, but electric field vector is perpendicular to this direction oscillate, and also magnetic field vector also oscillate perpendicular to the direction of propagation. Okay, that was transverse in nature. And which property of light is proved that light waves are transverse in nature means here polarization. Okay, what that characteristic property is called what here? Polarization. Now, first of all, before understanding polarization, so what is ordinary light and how do you understand this? Okay, this is what about in the beginning. So from Maxwell's theory, we know that so light is electromagnetic wave which is traveling with velocity c is equal to 1 by mu naught epsilon naught, which is equal to 3 into 10 power 8 meter per second. We have seen. Direction C cap is equal to E cap cross B cap also we have seen, isn't it? So now, if you consider the ordinary light, so what is ordinary light? What is polarized light? We'll see first of all. See, when the source of light is emitting, okay, light in all directions. So electromagnetic waves are generated and traveling in the all directions over here. Randomly they are produced, no? Isn't it? So so light is traveling in all directions. So when you are traveling, light is traveling in particular direction or all direction, a particular point if you observe, so we have electric field vector oscillations, magnetic field vector oscillations. Generally, in the beginning also I mentioned, whenever you want to understand the light, we always focus on its characteristic, this electric field vector. Okay, light means what here? We talk about its electric field vector only we'll talk. So your electric field vector is here oscillating. Okay, so At a particular instant, see, in case of ordinary light, okay, so if this is the direction of propagation, so for this in perpendicular direction, electric field vector and magnetic field vector is oscillating. So if I imagine a plane perpendicular direction of propagation, okay, so why? Because electric or magnetic field vectors are what? Oscillating perpendicular direction of propagation. Direction of propagation, if I imagine like this, and if I imagine a plane perpendicular direction of propagation. So in this plane must be what? In this plane must be electric field vector. So if I consider the oscillations of electric field vector in case of ordinary light, so this electric field vector, whichever is over here, no, it is oscillating. So these oscillations of electric field vector are confined in all possible directions in case of what? All possible directions. This direction electric field vector oscillates, this direction electric field vector oscillates. But because we have so many large number of waves, at a particular point in the space, if you observe the electric field vector oscillations, so all possible directions electric field vector oscillations are existing in case of ordinary light. In case of what? Ordinary light. Or one more way of saying is that to perpendicular, the direction of propagation is like this, no? Direction of propagation is in this way. So in this one we have a plane. This is a plane which is perpendicular direction of propagation. So in this plane, electric field vector oscillates in this way, okay, in this way. So about this direction of propagation, electric field vector is symmetrically distributed oscillations. The oscillations of electric field vector are symmetrically distributed in a plane which is perpendicular direction of propagation. So this kind of light we call as what? Ordinary light. So if a light in which electric field vector oscillates symmetrically in all directions in a plane perpendicular to direction of propagation. Because so direction of propagation is like this, electric field vector oscillates perpendicularly only. So if I imagine a particular plane perpendicular direction of propagation, in that plane electric field vector is oscillating in all possible directions, like this. Okay, but because so many waves are there, if I consider a particular electric field vector, it has vibrations and oscillations confined in the plane perpendicular direction of propagation. So with all possible directions. So our one more way of saying, with respect to direction of propagation, in a plane perpendicular direction of propagation, electric field vector is distributed symmetrically. Electric field vector is what? Distributed symmetrically. This kind of light we call it as what? Ordinary light. So now, ordinary light is the one. Ordinary light is the one. Okay. Ordinary light is the one in which the oscillations of electric field vector are okay. So ordinary light is the one in which the oscillations of electric field vector are in all possible directions, in a plane which is perpendicular to what, sir? In a plane which is perpendicular to direction of propagation. Following all of you? So ordinary light is the one in which the oscillations of electric field vector are in all possible directions in a plane which is what? In a plane which is perpendicular to, you can see the board here, no, which is perpendicular to direction of propagation. Yeah, this is what? Ordinary light. So actually light is electromagnetic wave, okay, in which we are saying the transverse in nature. Which property of light is mentioned? Transverse polarization. So what is polarization? Before understanding polarized light, first of all, what is ordinary light? So if you observe, we are talking, whenever we are saying light, we always talk about electric field vector of the light. So when an electric field vector is oscillating and those oscillations are confined in a plane perpendicular direction of propagation. So if I imagine a plane perpendicular direction of propagation, in that plane all possible directions electric field vector is oscillating. Okay, this kind of light we are calling as what? This kind of light we are calling as ordinary light. Okay, yeah, next. So what happens now in case of polarized light? So the symmetry of this particular oscillations of electric field vector will be, okay, what you can say, eradicated. And the oscillations will be confined to a single plane. Oscillations, of course, now also plane only, but single direction you can say. So if the oscillations of electric field vector are restricted to confine in a plane in one particular direction, such kind of light is called what? Polarized light. Such kind of light, what we call it as? Polarized light. Okay, first write on this one, definition of ordinary light. No, you can say polarized light. So now in case of ordinary light, we have oscillations of electric field vector are confined in a plane in all possible directions. Electric field vector oscillates like this, in this way, at instant, in this way, in a plane. Okay, so if I imagine a plane, this is one plane. Okay, which is perpendicular to what? Direction of propagation. So in this plane, all possible directions confined. But if I restrict the oscillation somehow the other, so to a single, same plane may be single, but oscillations are confined in particular direction. Okay, so this one writing for everyone. Students who are hearing virtually. Yes, Ray. Can you hear me?
Yes.
Right. So this part I'm now removing this one. So now polarized light means you see what is polarized light? We will see here. Now this is a plane, this is ordinary light. Direction of propagation is this one. This is ordinary light. Okay. Now what is polarized light means here? So in a plane, of course, which is perpendicular direction of propagation. Okay. If the oscillations of electric field vector are confined in a particular direction, the oscillations may be lying in this plane. The oscillation may lie in this plane. Direction of propagation is this one. So and representation of ordinary light is the same. See here. So this oscillation may be in the plane and perpendicular to plane also. Okay, therefore, so those oscillations which are lying in a plane perpendicular direction of propagation, they are represented like this, parallel arrows. See, this is a plane. If I imagine this is the plane, this is the direction of propagation. So here electric field vector may oscillate like this, in this way. Okay, so in this way, in this way undachu, or in this way also undachu. So kabatti, so those oscillations are lying in this plane. Okay, so they parallel to plane are represented like this. Okay, and perpendicular to plane are represented, perpendicular to plane also may oscillation may be here. So those are represented by dots. So generally we call, so if the oscillations both in parallel to plane and perpendicular to plane, if they exist, this kind of light is called ordinary light. This kind of light is called what? Ordinary light. Both parallel components are there, perpendicular components are there. So ఈ plane లో తీసుకుంటే మీరు ఈ plane కి డైరెక్షన్ ఇలా ఉన్నట్లయితే ఏమవుతుంది? So in this plane, like this also there. Okay. So in this way parallel ఉన్నాయి components, ఇలా కూడా parallel. So ఇలా ఉంటే perpendicular components. So if the all vibrations are expressed, that is called ordinary light. And direction of propagation is like this. So if the electric field vector oscillations are confined to the plane, and if they are what? Single plane here. So single direction here. Single direction. This kind of light is called polarized light. The oscillations may what? Perpendicular to the plane would undachu. Okay, for example, now this is the direction of propagation anukundam. So this plane is also this plane. This plane is perpendicular direction of propagation. Yes or no? And so if this plane is there, parallel, but vibrations may be like this. Vibrations may be in this way, which are perpendicular to again what? Direction of propagation. Okay, therefore, now these oscillations you can say restricting the oscillations of electric field vector in one particular direction in a plane, perpendicular direction of propagation. That phenomenon known as what? Polarization. And this kind of light in which oscillations are restricted or confined in one single plane in single direction, that is known as polarized light. Okay, right, definition of polarized light. Yeah, polarization is a phenomena. Polarization, definition and polarization is a phenomena in which Polarization is a phenomena in which the electric field of a light wave, polarization is a phenomena in which the electric field of a light wave is restricted to lie, electric field of a light wave is restricted to lie in a single direction, in bracket or single plane, single direction or single plane, how that plane must be perpendicular direction of propagation. So in a single direction or single plane, okay, single plane comma perpendicular to the direction of propagation. So polarization is a phenomenon in which the electric field of a light wave is restricted to lie in a single direction or single plane, perpendicular to the direction of propagation. Perpendicular to the what? Perpendicular to the direction of propagation of light. Full stop. Next line. Change the paragraph. Next line. We talk about ordinary light, unpolarized light. If the electric field lies, if the electric field lies in all directions, if the electric field lies in all directions, it not only components, okay, not only like this, that is in this way also, perpendicular direction propagation. Okay, if electric field lies in all directions, in all directions, in a plane, normal to the direction of propagation, then the light is said to be unpolarized light. Draw the diagram. In a plane, perpendicular direction of propagation, electric field vectors are what? Oscillating in all possible directions, not only plane, perpendicular to plane also. Okay now? In all possible directions. So both it having parallel component, perpendicular component. This is a representation of unpolarized light. Direction of propagation. This is a plane. So in all possible directions are there. In the plane are there, perpendicular to plane also there. So any directions to vibrations okay, that such kind of light is called ordinary light, or you can also call unpolarized light. Draw the diagram.
Sir,
Yes, Ray.
sir, so at a particular point, like electric field can have any direction perpendicular to direction of propagation.
Yeah, it can have any direction, perpendicular direction of propagation. So, see, direction of propagation, one time electric field vector must be perpendicular direction of propagation. So, what are the possible directions are there? It may be in X direction, it may be in Y direction. Three direction we mentioned, no, three dimensional, no. If it is X direction propagation, electric field vector may oscillate like this. So, in this plane, oscillations are what? Anyway, no, like this. So, ila unna kuda, it is like this, perpendicular direction propagation. If it is like this, if at all normal, perpendicular direction. Okay, so in this plane. Or one more plane, what you can take? You can take this plane, E plane, this portion. So oscillations may like this also. In this way. So X and Y Z, if the direction of propagation is Z direction, electric field vector may oscillate like this, Okay, any direction in this part, in these two planes. It must be perpendicular to direction of propagation. Okay? Clear? Your doubt is clarified, right?
Yes, sir. Thank you.
Yeah. Now see here, this is about unpolarized light. Next line. You can write about polarized light. You can write next what? Polarized light. Yeah, a beam of light in which, next, a beam of light in which the electric field vectors, a beam of light in which the electric field vectors, a beam of light in which the electric field vectors are not symmetrically distributed, are not symmetrically distributed, are not symmetrically distributed around the line of propagation. A beam of light in which the electric field vectors are, this is symmetrical distribution, means unpolarized light. If confined to a single direction, that is polarized light. So if a beam of light in which the electric field vectors are not symmetrically distributed around the line of propagation, around the line of propagation, around the line of propagation, then it is said to be polarized light. Then it is said to be polarized light. This is restricted direction. Electric field vector is supposed to oscillate, okay, in one particular direction. And this, how this plane is? This plane is perpendicular direction of propagation. So this kind of light is called what? This kind of light is called polarized light. This kind of light is called what? Polarized light. Now the oscillations may be perpendicular to plane also, no? So this is the plane, may lie in this particular plane also. Direction of propagation is like this. This plane must be perpendicular direction of propagation. Oscillations may be in this plane or perpendicular to this plane. So if direction of propagation, if it is like this, and if I have a plane like this, so if the electric field vectors are oscillating, how? Perpendicular components are given by dot here like this. Okay, what kind of this one? It is given by dot. Perpendicular to this plane, perpendicular to this plane. This is also called what? Polarized light. Okay, so generally what we can say now, so it is this one. So this indicates perpendicular to the plane. Okay, so if this is like this, in this way. If it is like this, in this way. So vibrations of electric field vector are perpendicular to this plane. Because they may be what? They may lie in the plane, they may be perpendicular. And this plane should be perpendicular to what? Direction of propagation. The conclusion is that if the oscillations of electric field vector are restricted to a single direction, that direction must maybe lie in the plane which is perpendicular direction of propagation, or those vibrations may lie perpendicular to this plane which is lying perpendicular to the direction of propagation. So such kind of light is called what? Such kind of light is called polarized light. So restricting the vibrations of electric field vector in a particular direction in a plane perpendicular direction of propagation phenomenon is known polarization. Okay, I hope everyone understood. So ordinary light vibrations in all possible directions in a plane perpendicular direction of propagation. Here direction of vibrations are confined in a single plane, restricted to single plane, restricted to one direction also you can say. Of course, single plane, in that plane also in one direction. That is known as what? That is known as polarized. Okay, from these two diagrams I'll end it. Yeah, notation of different types of light: polarized, unpolarized, and partially polarized. So if all possible vibrations are there, means unpolarized light. Unpolarized light. Unpolarized light means it is having vibrations parallel to plane as well as what? Perpendicular to plane. All possible directions are available. This is called unpolarized light. If what is the polarized light? In one direction, and the restriction of electric field vector, polarized light. Electric field vector is confined in a plane perpendicular direction of propagation, and these vibrations may be parallel to the plane, or this vibration may also be what? Perpendicular to the plane. Okay, perpendicular to the plane. Polarized light. Sometimes we have partially, some confined to one particular direction. Partially means not completely polarized. Not completely means not completely ordinary light, not completely polarized light. Okay, that is called what? Partial polarized light. Set up this diagram, right? All of you, restricted in one particular direction, in a plane perpendicular direction of propagation. That is called what? Polarized light. Vibrations may be parallel, vibrations may be perpendicular. Perpendicular vibrations are shown like this. And ordinary light, one more way of representation is what? It has electric field vectors oscillating in all possible directions. In a plane, perpendicular direction of propagation. That is called ordinary line. Some are confined to a single plane but particular direction. That is called polarizing. Sometimes partially polarized line. Partially polarized. Means it has both components. Some components in parallel to the plane. Okay, some components in perpendicular to the plane. So some are confined here, some are ordinary components, some are what? Confined component of electric field vector. That is called partially polarized line. Now, after this we study what is a Polaroid. What, sir? What is a Polaroid? And how do we convert ordinary light to polarized light? See, first draw these two diagrams. Yeah. So what are polarides? You might be seeing sometimes we are seeing polarides we are using for weaving the 3D films we are using, and this kind of plastic sheets of this material, known as polarides, we are using in the window planes of aeroplane. So to remove the glare. What happens when you are going in a plane? No? So what happens now? So sunlight starts reaching, no? So it may cause what irritation effects on our eyes. So windows of the planes, aeroplanes are covered with this kind of polarized sheets. What are polarized sheets? Polarized sheets are specially designed with thin plastic materials. Okay, so actually which absorb the light, and remaining some components of light will transmit. Okay, so what happens? They are made up of some specially designed materials. You can say we call tourmaline crystal, we call calcite crystal, calcite. Names, these are the names of these materials: calcite, tourmaline. Okay, these are what happens. So in these, actually, molecules are there. Okay, you can say what you can say the structure of these materials are such that. Okay, so in all these materials, plastic materials, chemistry very well done me, isn't it? So we have plastics comes under what, right? Polyvinyl chloride, something we say, no? Isn't it? Plastic materials. What are the compositions of plastic materials in chemistry? Huh? Polythene. Yeah, polythene is what? A plastic, no? Polymer it is, isn't it? So we have certain materials called, you can say, polymers, specially designed these thin sheets, in which the alignment of molecules will be different. So what happens, no? So when these particular, and there is one direction, so this is what the chain of molecules will be arranged in particular direction, particular fashion, perpendicular to this particular direction. So chain of molecules, for example, like this, or chain of molecules are arranged in this proper direction, all here. So perpendicular to this particular chain of molecules, okay, when unpolarized light, so whose components are confined all possible directions. This is the plane Kunam. Okay, so our ordered light is here. So if I'm inserting ordered light, if I place a crystal like this, okay. So here these electric field vectors are oscillating in all possible directions, no? So the electric oscillations of the electric field vectors, when they passes through this particular material, this material molecule, they will absorb the electric field vectors, okay, and transmit the what? Certain components of light. So the direction in which they transmit, for example, in this direction, electric field vector oscillations are transmitted. Then we say path axis of this crystal is in this direction. So those electric oscillations of the electric field vector which are along the path axis, they allow in the direction. In other directions, the molecules are the what you can say the molecules of this particular polaride, they are absorbing the electric field vectors and they are allowing only one particular direction. This technique of absorption of electric field vectors, okay, by this particular thin sheets is known as dichroism. What's a selective absorption technique we call? Selective absorption technique. Selective absorption technique. And this is called dichroism. Dichroism. So what happens when you are sending an ordinary light to pass through certain particular specially designed thin sheets of materials called polarides? In this, depending on the arrangement of the molecules, in one particular direction, the electric field vectors will be allowed. So that particular direction of this particular polaride is known as path axis of the polaride. So when electric field vectors like this oscillating electric field vectors are coming outside, means the path axis of this particular polaride, path axis of the polaride is in this direction. And this direction is perpendicular to alignment of molecules. Keep in mind, perpendicular to alignment of molecules. So remaining all directions, electric field vectors are completely blocked. They have been absorbed. Only in one particular direction, electric field vectors are allowed. Such kind of technique is called what? Selective absorption technique, which you call as what? Dichroism. And electric field vectors remaining all components of electric field. See. So this direction component, this direction component, this direction component, this direction, all possible directions symmetrical, no? Any directions to make. Okay, all directions. But only one direction electrical components are allowed, remaining all are being absorbed. The direction which is allowed, no, that is called path axis of this polaride, and this confined to a single plane, and that particular plane which is the perpendicular direction of propagation. Therefore, E plane the E components, parallel components. Or sometimes it may also what? So this the thin sheet is there now here, an unpolarized light is incident over here. Direction of propagation is like this. So in this plane, so perpendicular vibration of sometimes allowed. So in perpendicular direction may also allowed. So this then the path axis must be what direction? Path axis of this particular polaride must be this direction. How the molecular alignment will be? Molecular alignment is perpendicular to the what? Path axis. So this vibration is, see, this is a plane now. Vibrations of this particular plane. If these vibrations of electric field vector are allowed, that means path axis direction of this crystal is in this way. What I mentioned, alignment of molecules is perpendicular to path axis, means alignment of molecules in the direction, particular crystal. Therefore, the direction in which oscillations are allowed is the path axis direction, perpendicular to path axis. The alignment chain of molecules are arranged here. Okay, this is what selective absorption technique we call, and this kind of materials are called what? Polarized. Okay, around definition of polarized. Electric field? Electric field vectors, these are only this light only. In this light, electric field vectors are oscillating. Direction like this, no? This is the plane, no? So these vibrations are coming outside from this path axis, and this direction they are blocked. Other directions are blocked. But sometimes what happens, no? So one more again still discussion is there. Don't worry. For example, these vibrations are there. Which one will allow? This is electric field vector. No, this is E. Say path axis is like this. Path axis is like this. So if I resolve this particular vector into components, one component along the parallel axis E cos theta, and there is what? E sin theta. So this electric field, let's see. This is the path axis direction, this one, right? This path axis direction. Ila undi. So electric field ila unnai, oscillations ila unnai, all directions unnai kada? Ila unnai direct వెళ్ళిపోతాయి. Okay, ఇలా ఉన్నాయి బ్లాక్ అయిపోతాయి. సో ఇలా ఉంది అనుకో, కొంత యాంగిల్ చేస్తుంది ఇట్లా ఉంది, కొంత యాంగిల్ చేస్తుంది ఇట్లా. This vector is electric field vector is oscillating like this, no? Making some angle with the path axis, this theta. Result to component E cos theta, E sin theta. So this E cos theta, E sin theta. Now for this axis, now E sin theta is perpendicular. It is absorbed by the material. E cos theta is parallel. It comes out. So only if they are not in exactly path axis direction. So take component of the electric field vector the direction of the path axis. Those components are allowed outside. Perpendicular components are blocked. Perpendicular blocked here. So like this, the what happens now? So only in one direction oscillating electric field vectors only allowed. So the electric field vector oscillations are confined in a single direction in a plane which is perpendicular direction of propagation. This kind of light what we call as? This kind of light we call as polarized. This one. Heading definition 9. Polaroid. Polarides are thin sheets of. Polaroids are thin sheets of. Polarides are thin sheets of specially designed plastic material. Polarides are thin sheets of specially designed plastic material, which are generally used to get what light? Polarized light. Which are generally used to get polarized light. Polarized light by selective absorption. By selective absorption technique. By selective absorption technique. By selective absorption technique known as dichroism. 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 So polarides are the specially designed plastic materials which are used to get what? Polarized light by selective absorption technique known as what? Dichroism. Is known as what? Dichroism. Okay. After this, keep adding pass axis of the polaroid. What is pass axis? Yeah. What is pass axis of the material? When this particular what? Ordinary light when passed through the specially designed crystal, the oscillations of electric field vector are aligned in particular direction. The direction in which they are allowed is called pass axis, which is perpendicular to what? Perpendicular alignment of the molecule. And that direction we are calling as what? Pass axis of the polaroid. Okay, the definition. When an unpolarized light wave is, heading definition of pass axis. When an unpolarized light wave is, when an unpolarized light wave is, when an unpolarized light wave is incident on a polaroid, the light wave will get linearly polarized. The light wave will get linearly polarized. This is unpolarized light, UPL. This is a linearly polarized light. Sometimes we also call plane polarized light. LPL, PPL, IPL, and IPL must happen, but unpolarized. So when an unpolarized light is, when an unpolarized light wave is incident on a polaroid, the light wave will get what? Linearly polarized. The light wave will get linearly polarized with the electric vectors, with the electric vector oscillating along a direction, with electric vector oscillating along a direction. And what direction? Oscillating along a direction perpendicular to alignment of molecules. Okay, oscillating along a direction perpendicular to the aligned molecules. Perpendicular to the aligned molecules. Perpendicular to the aligned molecules. This direction is known as pass axis of polaroid. This direction is known as pass axis of polaroid. Now, look at the board. Permanent crystal, ordinary lights. It is plain polarized lights. This is the direction in which electric field vectors are coming. This must be the direction of pass axis, which is perpendicular to alignment of molecules of the what? Polaroid. So now unpolarized light is falling here. So polarized light. So these components which are in the direction, they simply allow. This direction they are common. This direction they have, you have to resolve into components electric field vector. One is parallel component to pass axis and one is perpendicular to pass axis. Perpendicular to pass axis direction, the alignment of molecules, isn't it? That is absorbed by the molecules. Only parallel component is allowed outside. Like this, the electric field vectors oscillating in particular direction only allowed to pass it. Therefore, electric field vectors are constricted to oscillate in particular direction. This kind of light is called polarized light. You can say linearly polarized. In one particular direction, these alignments are restricted. Okay, this is what. Draw the diagram. This is what is tomorrow in the exam they may ask. What is path axis of the polaroid? Path axis of the polaroid is the direction in which what electric field vector oscillators are allowed, which is perpendicular to alignment of molecules of the polaroid. That is called path axis of the polaroid. Yeah. Next you see. So rub this diagram. After drawing this, you can draw this. So all direction, only path axis direction are allowed. If they are not, they take a component in the direction of path axis, they are allowed. Perpendicular components are blocked by the polaroid molecules. This diagram drawing over. What are the types of polarides? Calcite crystal, tourmaline crystal. These are the names of the polarides, which what they are made up of. Tourmaline crystal, you can say, polaride. See, where we are using polarides, we are using polarides in the car headlights to remove the glare of the light. The most protect the light. Glare is against one direction light we use polarides. In window frames of aeroplanes, we use polarides. So sometimes we see the sunglasses. In sunglasses, polarized glasses we are using. Why? Because entire light may damage our retina. So what happens now? Intensity will decrease definitely, and moreover, so what you can say, components, only few components of light are allowed. That glare can be reduced. And also we are using 3D views in one particular direction. Okay, now polarized in a particular direction, different continuous multiple directions. So 3D views, 3D pictures should have also we are using what? Polarized. The glasses they will give, they're polarized glasses actually. For seeing the 3D movies and all. Where? Transparent sheets. Okay. It depends. Okay. Student में हमारा कोई back and forth करा. Lost ने light screen जो कोई back and forth. If occasion medium layer करा. If the angle is more than critical angle, whenever it happens it. But light entering from where? Air to glass entering. Radar to denser. Never happens. But condition is what for TIR. Light has to travel from denser medium to thinner. Yeah. This diagram over there. This is what path axis. Now you see, always keep in mind this question directly asked once in JEE. So if intensity of unpolarized light, which has vibrations of electric field vector in all possible directions, I can't draw like this. If I want, I can draw dot here also. So E direction, 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 which is a plane perpendicular direction propagation. In all possible directions. The symmetry we are removing. The symmetrical distribution of electric field vector oscillates we are removing and confining in particular direction. That is called polarized light. So here, when it passes through, any kind of crystal here, the path axis we are saying like this. Okay. So confined either this direction, light is allowed, or confined to perpendicular direction components are allowed. Single direction, that is called plane polarized light. Or if the confined in single plane, that is called plane polarized light. Direction is confined, linearly polarized light. So fine. Now what happens here when the path axis is like this? So certain components are there, this kind of components are there which are making some angle theta with the path axis. And see here, if intensity of light is I, So after passing to the polaroid, how much intensity of light is coming means I by 2 is coming. How much coming here? Then this is called as I naught. So where remaining I by 2 has gone? Remaining I by 2 has been absorbed here. Remaining I by 2 has been what? Absorbed by. Therefore, always keep in mind, after passing through a polaroid, if I is the intensity of light incident on the polaroid, the transmitted light intensity is half of the incident intensity on the polaroid. I by 2. That is I naught is the polarized light intensity. So what is happening here? So here, so this is the direction. So in this, in all possible directions, electric field vector has directions here. So 360 degrees. So if I take an instant, if electric field vector is having amplitude of electric field vector A is equal to E naught. So if I take the component of this one, this will be how much? A naught cos theta. So those components which are the direction of path axis of the polaroid, they are allowed. So if I can see intensity of incident wave, I is equal to here E naught square. So the intensity of transmitted light, will be how much rate? Some constant will be proportional to amplitude square. So So here you can say I is equal to some k into a naught square, you can say. So transmitted light will be how much now? So k into how much component is coming outside? A naught cos theta component is coming. So a naught cos theta whole square. This is transmitted light components which are parallel to those components which are in the direction of path axis. Those only allowed. Remaining are black. Okay, if this is component in this particular direction, take cos theta. If this is in this direction, path axis like this, take its component. If vector is in this way, oscillating electric field vector is in this way, take its component. Okay, so only components are coming. So what is the intensity of transmitted light? So k into a naught cos theta whole square. But this theta is what? All possible directions. About direction of propagation, electric field vector has symmetrical limits. How much round degree? 360-degree vibrations are possible in all possible directions. So if I take the average intensity of transmitted light, if I take average intensity of transmitted light, if I take, so here k into a naught square into average of cos square. Average of what? Cos square theta. And average of value of a function we know already. How we have found average of any function? Average of a function f of t space average time average is equal to integration 0 to t f of t dt divided by integration 0 to dt. This is the time average. Isn't it? So if I take average value of this function, so what you have to do here? That is equal to integration from where to where you have average 0 to 2 pi. So how much here now? Cos square theta d theta divided by total angle how much here? 2 pi. If I simplify by writing 1 plus cos 2 theta, 2 cos square theta by 2, no? 1 plus cos 2 by 2. If I simplify, the average value of cos square theta is 1 by 2. How much average value of cos square theta is? 1 by 2. So k a naught square into 1 by 2. What is k a naught square? K a naught square is the intensity of light, which is actual unpolarized light intensity. So in this one, how much coming it is? This is I divided by 2. This transmitted light coming out of the polarized, we are calling it as I naught. Therefore, this is very, very important point. Once aim and direct question asked, the intensity of transmitted light, okay, through the polarized is equal to, if I is the incident light, I by 4, I by 2, I by 3, I complete transmitted. How much? Only half of 50% of light only transmitted intensity. Remaining is completely blocked or absorbed by the what molecules of this particular plastic material called polarized, a particular polymers you can say. Right, make it fast. It's very important point. Yeah. Writing part over everyone. Only we have two laws here, different polarization. Malus law, Brewster's law. If these two laws if you finish, polarization gets over. Definition of polarized light, definition of unpolarized light, intensity. So if you know 2-3 numericals are Malus law. That is syllabus for polarization. Only it allows, keep in mind, components which are on the direction of path axis will come outside, remaining will be blocked. If some angle is then components in the direction of path axis you can take, those are allowed, nothing else. Yeah. You can simplify this expression, it comes to 1 by 2 for you. 1 plus cos 2 theta by 2, Rashi integration change. We'll get the answer by get cancelled by me to 1 by 2 also. This diagram over everyone. Hello, virtual boys, can you hear me?
Yes, sir.
Ready? Ashra? మాట్లాడండి రా కంప్లీట్ చేయొచ్చా
Yes, sir.
రైట్
Yes.
I think some idea you got what is polarization. Okay, so intensity decrease indefinitely glare decreases no, so wherever you want to decrease intensity just keep a polarized. Intensity will be decreased, and component, all direction components are blocked. Only one particular direction components are allowed. If, for example, if you want to light to allow pass the direction, no, if you want these components, it make pass axis like this. No, I want only these components. To keep pass axis of the crystal like this. So these components will only allowed like this. This direction components are blocked by this two, or permanent or calcite crystal. Okay. So right. Now here, now we have what you can say. Now analysis, what you can say, how to identify polarized and unpolarized light. So one we have polarizer, and we call analyzer. Now and that law is called as the Malus law. What law? The scientist Malus law. So what he has done, so we have, when already know that when you are incidenting unpolarized light, which has electrical field vector oscillations in all possible directions. Okay, so in a plane, if you consider in a plane, look at this perpendicular direction of propagation. In this plane, in all possible directions, unknown components. So if you allow to pass through a particular polaroid, the pass axis of the polaroid is like this. This is pass axis of polaroid. So these components of only directions in which pass axis direction, they only come outside. Remaining all are blocked. If at all any component is having this kind of angle, only those components of electric field vector which are in the direction of pass axis, they are allowed. Remaining all are blocked. And we have seen if intensity of this light is I, intensity of light coming outside is I by 2 after passing through the polaroid. So this is polaroid is P1. Now this light, if I again allow to pass through another polaroid, okay. So for example, so pass axis is like this. Now, if I have this polarized, this is unpolarized light, UPL, unpolarized light. So linearly polarized light, or you can say plane polarized light, you can say. So these electric field vectors are in the direction they are passing. If the pass axis of next polaroid, this is P2, is the direction of this one, all components will come directly as it is outside. Yes, sir? No. Intensity of this plane polarized, linearly polarized I0, this also will be I0. This is not ordinary light. Arthamadunda, matladedi. So entire will be what? I0 by whatever this light is incident in I0, same transmitted light intensity also I0. But if I may, this is P2 polarized. Now this light which is coming here, whose intensity is half of the incident intensity. This is now I0, which is equal to I by 2, where I is intensity of incident time. Intensity of unpolarized light. Polarized light is I by 2. This I by 2 now pass light. If I rotate this crystal axis like this, before axis rotation was this one, now if I rotate this pass axis like this. Now, what happens? So these components of electric field vectors are coming like this, pass axis angle is making as theta. Now it allows only those components of electric field vectors which are in the direction of what? Pass axis. So what is the component electric field in the direction of pass axis will be this amplitude vector if it is A. Atom A naught. A cos theta only direction also? Yes or no? A cos theta. So here A cos theta is coming outside. A cos theta is coming. So if I consider intensity of transmitted light, I will write here. If I consider intensity of transmitted light, you can see here, no? That is equal to how much now? This amplitude whole square, no? So its amplitude is A. I0 value, how much I am calling as A square, for example. K A square you can write. I proportional to A square. So I0 I am calling as A square. That means electric field vector amplitude of oscillation is A. When this A falling on this, if I rotate this crystal through angle theta. So only this particular crystal or polaroid only allows those components of electric field vector which is the direction of what? Pass axis. Therefore only A cos theta. What is the intensity of transmitted light will be? Square A cos theta whole square. This will be how much now? A square cos square theta. What is A square? Intensity of what? Light after passing through first polaroid. That is I0. This is I0. cos square. This is I. So this line is called Malus law. This line is called what? Malus law. If I put theta is equal 0, what the meaning of theta is equal 0? First unpolarized light is passed here. This is first polarized. So electric field vector came like this. Okay. So if I am keeping now the electric field vector is this is one electric field like this. Now this another polarized axis, past axis. If this parallel there, no theta is equal 0 between them. So cos 0 is 1, I is equal I naught. That's the entire light of intensity I naught has come outside. Entire intensity of light, how much? I naught has come outside. Are you following everyone? Now, so if make the angle like this, if I make this is past axis of this one, past axis of this one. If the angle is like this, theta angle between these two axes, how much coming? I naught cos square theta. If I make theta 90 degrees like this, past axis of this polarized is like this. Past of this polarized is in this way. This kind of crossed polarized. They are called what? Cross. If the angle between the past axis of two polarized is 90 degrees, they are called crossed polarized. They are 90. How much will come? Cos 90, 0. So no light will come outside. Entire light is upside. Why? Because all components are perpendicular to what past axis. No light will come. These are called crossed polarized. If past axes are parallel, they are called matched polarized. They are called what? Matched polarized. Right. Next heading, Malus law. And see, this is called polarized. This is polarizer. This is analyzer. This analysis, no? How much the angle is coming outside? You're analyzing the polarized light. So this is called polarizer. This is called analyzer. This is called polarizer. It converts polarized light, and it is analyzing the polarized light. How much it is coming outside? This is called analyzer. So polarizer and what? Analyzer. I don't know. Malus law. When an unpolarized light of intensity I, when an unpolarized light of intensity I is passed through a polarized P1, when an unpolarized light of intensity I, capital I, is passed through a polarized P1, the transmitted light, which is what, right? Plane polarized. The transmitted light, which is plane polarized, the transmitted light, which is plane polarized, will have intensity, how much, sir? Half of the intensity, I by 2. Why half? Already we explained. Okay, so the transmitted light, which is what? Plane polarized, will have intensity, this one, I naught is equal to I by 2. I naught is equal to I by 2. Full stop. If this light is passed through second polaroid P2, if this light is passed through a second polaroid P2, if this light is passed through a second polaroid P2, the intensity of light transmitted, by second polaroid, in bracket analyzer, the intensity of light transmitted by second polaroid in bracket what? Analyzer depends on the orientation of the pass axis, depends on the orientation of the pass axis, depends on the orientation of the what? Pass axis of polarized P1 and P2. Of pass axis depends on the orientations of the pass axis of the polarized P1 and P2. We'll stop. Next line. If theta is the angle between, next line. If theta is the angle between two pass axes, if theta is the angle between two pass axes, rotate like this, no? If theta is the Angle between two this path axis you can say trilateral. So angle is theta. Theta is the what? Angle between the path axis. If theta is the angle between two path axes, intensity of light transmitted through P2, intensity of light transmitted through P2 is given by IT is equal to I naught cos square theta. IT is equal to I naught cos square theta. What is I naught here? What is I naught? I naught is the intensity of light after passing through first polarized, which is half of the intensity of what? Incident light. Understood? So, you know what I naught is what? Intensity of light after passing through first polarized. Theta is what? Angle between path axis of these two polarized. So, IT is equal to I naught cos square theta. This is known as Mahler's law. This is known as Mahler's law. This is known as what? This is known as Mahler's law. In diagram, Raj, see how it has come. Only component direction of path axis are allowed, no? That's how IT becomes I naught cos square theta. Take the second right. Match polarize, cross polarize. Match polarize. So if I have polarized, you can draw polarized as a circle with this goes up and down. If this path axis of polarized is like this. Okay? Another polarized also we have. Another polarized also we have whose path axis is like this. You can match them now. So their path axes are coinciding. So what happened now here? But the angle between their path axis is here, 0 degrees. This kind of polarized are what? Matched polarized. Polarized P1, polarized P2. P1, P2 are what? Matched polarized. If path axis of this polarized is this direction only, okay, it allows the light. So alignment of molecules will be perpendicular to this one like this. Okay, so that I am not mentioning here. Only path axis. This is P1. So another polarized if I have, if its path axis is like this, angle between the path axis of this polarized see here. These are what? Path axis are angle between the path axis is 0 degrees. This is called matched polarized. Angle between them is 90 degrees. This is called crossed polarized. What you can say here? These are what you can say crossed. $90 degrees. This is 0 degrees. Okay. Are you drawing the diagrams? Now, how to identify polarized light, unpolarized light, and partially polarized light by this phenomenon of analysis? Okay, that we'll be seeing now. For example, one light is given to you. How to identify whether the light is what kind of light is a polarized light or unpolarized light? What kind of light it is? So here, see. At this part now, for everyone, this derivation over writing part, Mahler's law. Let's see. So here, an identification of light. So if I, for example, unpolarized light, if I incident ray. If unpolarized light, say for example, analyzer, you can take this analyzer, you can take. So for example, on this analyzer, unpolarized light which has components in all directions incident. So when all directions, see, this is having components this direction, this direction, this direction, this direction, this direction, this direction. Anni 360 degrees round up లో ఉందన్నమాట. 3D లో మాట్లాడితే 4 pi steradian angle. 4 pi what? Steradian solid angle లో ఉన్నాయి. అర్థమవుతుందా? So in all directions are there. So if you allow to pass to this kind of analyzer, and even though if you rotate this analyzer to any angle, so if you rotate all are possible directions, no? Also, though the change the direction, they will be coming outside. If you orient again, you change the orientation, in those direction components will be coming out. So if you rotate this analyzer, if an unpolarized light is here, what? Incident on this one. So there is no change in intensity. Why? Because unpolarized light has components in all possible directions. So if there is no change in intensity, no change in what? Intensity. Then you can say that if you are in just what happened now, so beam of light is falling here like this. So by taking this one as along the axis, rotate this one like this. When you are rotating this polarized, if you observe that there is no change in intensity, yeah, this light is unpolarized light. Now sometimes what happens now? So plain polarized light if you are incident. What is plain polarized light? Either vibrations are in this direction or vibrations are perpendicular to this direction. When this kind of light passes through a polarized, only it allows those components in the direction. Remaining is blocks. So when you are rotating intensity varying according to what formula? IT is equal to I naught cos square theta. So if intensity is what? When angle become what? 90. See, this is the direction polarized light ray. Pass axis ila unnappudu entire light is coming. Rotate this one. Angle is what? Increasing. Intensity decreases. When angle becomes 90 degrees, intensity becomes 0. Again, when angle is what happen? After 90 again it increases. No, slowly, intensity also increases. Becomes maximum and become parallel. Again, when you're rotating like this, no, again 90 becomes 0. So even complete rotation, the intensity of light becomes 2 times maximum, 2 times minimum. Okay, 2 times no, for the maximum undi. Next minimum. Again what? Maximum. So 2 times maximum or minimum if it happens, then the light is what? Polarized light. And light is what? Polarized light. So here what? Intensity what? 2 times maximum. 2 times maximum or what? 2 times minimum. Then that light is called what? That light is called plain polarized light. That light what we call? That light we call it as? That light what we call, right? Plain polarized light we call. So if partially polarized light if you are having, plain polarized, partial polarized, partial polarized light. Okay, if you are, so this has some vibrations parallel component, some are having what? Perpendicular component also. Partially polarized. So then what happens? Intensity will not become 0. Some finite intensity will be there. Intensity will not become what? 0. So unpolarized light, no change in intensity. Plain polarized light, intensity become what? Maximum and what? Minimum. Maximum is maximum, minimum is 0. But unpolarized, partially polarized light is incident, no. So when partially polarized, this path axis is incident here, it has components this direction also, some components maybe. In this one, only few components are allowed for any rotation, but because whatever here, some all direction components are also present here. So whatever, even though if you make it 90 degrees here, so some components may present in the direction also, no, they will be coming outside. So intensity completely will not become 0. Then and moreover, intensity variation is there. Intensity is varying but not becoming perfectly 0, not perfectly become maximum. Then we can say that that light is called what? That light is called partially polarized light. Okay, this is how we identify by means of analyzer the type of the light and what is the intensity of transmitted light. Okay, by means of another polarizer called analyzer, IT is equal I naught cos square theta. This light is called what? Malus law. So we have said what is the phenomenon of polarization? Removing the symmetrical distribution of or oscillations of electric field vector in a plane perpendicular direction of propagation and confining in a particular direction is called polarization. And the specially designed crystals we are using, they are called polarized. What is the path axis of polarized means what? And what is, we have seen a representation of polarized light and unpolarized light. And then we have seen what is the Malus law and how the intensity variations are there and how to identify the light, the polarized light and unpolarized light. This phenomena we have seen. Okay, make it fast. Now one more law is called Brewster's law. What law it is? Brewster. So what is Brewster's law? We'll be seeing now. Method of polarizing ordinary light. So the different methods are there. So we'll have only one method here. So we can have polarization by reflection, polarization by refraction, polarization by double refraction. Methods are only. So one method we have here. That is called what? Brewster's method. Yes, ma'am. Wait. when unpolarized is, so but you are varying the intensity, okay, changing what I call me, fine, ento kondu vachina kuda malla age rotate cheyadam valla intensity maradu. See, your student, your friend is classmate asking doubt is that this is fine, some intensity decrease, but when you are analyzing this intensity again for different orientation, intensity remains the same. Of course, it may become reduced to half, but in that again, whatever the light you are observing, again that intensity is not varying, rotating here on the screen. It remains how much that I will do only it remains. That is the meaning of it. Yeah. Next what? Methods of what you can say, obtaining polarized light. So you can say what you can call ordinary and elliptic. No. Methods of polarizing ordinary light. Methods of polarizing ordinary light. What do you mean by ordinary light? This is ordinary light, is not extraordinary light. Ordinary light is the light which has electric field components, vibrations in all possible directions. That is called ordinary light. So here what we do know? So by reflection we use this one. So the first method is by reflection. So what happens? So B will be, so this particular reflecting surface you can take. So light is incident. Which light is incident here? Ordinary. What is the ordinary light? Ordinary light has components parallel to the plane as well as perpendicular to the plane. So then this board plate is incident light is coming here. It's incident over here. Okay. So if you incident this light ray such that this is incident light ray, and we have reflected light ray. Okay, polarites are there now. So we have, so if like a glass plate is actually we have actually we take a glass plate here like this. Okay, arrangement of glass plates or glass plate. Light is incident here. So this light has all components, which is ordinary means all possible. Directions lo unnai, directions lo unnai. Armada. So ila kuda undachu, ila kuda undachu. That's why representation of ordinary light, all possible components, both parallel components and perpendicular components, some components angles also. So this kind of light is incident over here. So and reflected light is here like this, and some transmitted light also here. Or you can say refracted light also you can say. So if you observe at a particular value of angle, this reflected light ray, and this refracted light. All this question you have seen. So for what angle of incidence they are perpendicular? You can refer your question I have mentioned. So light is incident some particular angle such that the reflected light ray and refracted light rays are what? Perpendicular. And what is the refractive index? I have done this problem. If not, now you can prove it. See, refractive, all the equation concept is called mu is equal to tan theta p and sigma. So this angle, a particular angle of incident, if incident is ordinary light, reflected light, transmitted light. This transmitted or refracted light ray is partially polarized. Some components are perpendicular and some polarizing components are. Okay? Not all are parallel and dots live. Only plane component situation available. This is what some components are confined, some components are having all possible direction vibration. This kind of light is called what? This kind of light is called partially polarized light. This kind of light is called what? Partially polarized light. And if you observe suddenly here by this phenomena, when you arrange this, when you change the value of I such that this reflected light ray and refracted light ray both are perpendicular. In that case, the refracted light is having maximum components are confining some or all directions, partially polarized, and reflected light ray is having so components which are confined in one particular directions here, so which are perpendicular to plane of vibration. So this plane is there, no? The plane ki perpendicular to vibrations reflected light ray unnai. So దీనిలో కొన్ని parallel ఉన్నాయి, కొన్ని అన్ని components ఉన్నాయి. That means by inserting particular angle known as called polarizing angle, IP you can say. Polarized angle such that when incident, so on a glass plate or arrangement of glass plate such that the reflected light ray, refracted light ray, whenever they are perpendicular, then the reflected light is having plane polarized light. That means the electric field vector oscillations are confined in a plane which is perpendicular to the plane of incidence. Perpendicular or plane of incidence. So we are getting plane polarizing light. This is one method by which reflection will get the polarizing. Right, we analyze what is the refractive index of this material. If it is mu, angle of incidence if it is I, so relation between this polarizing angle, this angle when this two becomes 90, then only reflected light is what? Plane polarized. Whose plane of vibrations are perpendicular to plane of incidence? This is called what? Planing method of what? Polarizing light. And this is what? Partially polarizing light. So if I analyze and look at the board everyone, this is I, this is reflected in flux to I. This is refracted angle, this is R, this is 90 degrees. So you can write down now by geometry. What you can write here by geometry here? Yes. What I can write? So this entire angle is what? A straight angle, no? This is I, this is 90, isn't it? This is R. So you can write from geometry. Can you see the board all of it here? From geometry, this is I, this is 90, plus this is R. This value how much equal to? अरे यार straight angle है ना पूरा ये. Straight angle how much? 180 degrees. So you can write down I plus R is 90 degrees. R is equal to 90 minus I. Equation number 1. Right, everyone? Fine. Now next. So this is angle of incidence, angle of refraction. By Snell's law, what you can write? By Snell's law, refraction is the second medium. Second medium is glass. With respect to air is another medium. Is equal to sin I by sin R. Sin I by sin R. So this angle of incidence we are calling as what? For which the reflected light is plane polarized. It is not angle of polarization. Polarizing angle. What is I here? I is called what? Polarizing angle. You can call it polarizing angle P also natural. Therefore, this is mu is equal to sin I. I is called I polarized angle divided by R value. R value how much? 90 minus I. I means I polarized. This is sin R, no? Sin R, no? Sin of R means 90 minus I. I means here I. This is equal to sin I. So by sin of 90 minus theta, how much rate? Cos theta. Can you see the board, all of you? This is sin I p divided by sin of 90 minus theta is cos theta. Cos I. This is mu. Sin I by cos I is tan. Therefore, what is IP? Angle of polarization is tan inverse of mu. So for this angle of incidence, what happens? For this is tan inverse of mu. So for this angle of incidence, the reflected light is what? Plane polarized, whose vibrations are confined to plane perpendicular direction of the. This is observation, and this is the part of derivation. If you know the mu refractive index, you can obtain plane polarized light if you incident at this angle. I is equal to tan inverse of mu. And this law we are calling as method of polarizing by reflection, no? And this law we are calling as Brewster's law. Brewster's law. BREWSTERS, Brewster's law. Following all of you? Yes, students. Under Vintunara?
Yes, sir.
Yeah, this is what Mahler's law, and this is what Brewster's law. BREWSTERS, Brewster's law. Yeah, I mean, doubt unte adagachu. So unpolarized light incident. Okay, so when this reflected and refracted light rays, when they are what? Perpendicular, the reflected light has electric field vectors oscillating confined to a single plane. These vibrations are perpendicular to plane of incidence, and it is partially polarized. And this angle of incidence is called what? Angle of polarization, polarizing angle. Sometimes the board are asking the definition polarizing angle also. Okay, this is what will entire polarization rate. So next tomorrow morning, 5-10 minutes, I will spend time. Or after we have session, no? Yeah, two problems we will do. So polarization gets over. Tomorrow, new subtopic will start. Actually, 1 hour complete చేయాలి. I took 1.5 hours. Still, I will spend time. ఒక 10 నిమిషాలు spend చేసి will complete. So with this, diffraction polarization over. And I think already this weekend syllabus is already posted in the group. Posted or not? Yeah, by afternoon we'll be getting the syllabus also. Okay, what is the weekend syllabus? Okay, entire syllabus, whatever. And also the revision is going to start, right? Revision schedules also will be keeping in the group. So revision will give 1D motion, 2D motion only. దాంతో పాటు this weekend entire syllabus ఎంతనే ఉంది. Diffraction already చెప్పేశాం. Diffraction for exam it is there. And polarization also for this exam. And we also have transistors. Okay, so my logic gates transistor. Mostly probably tomorrow I will take logic gates. I will take diode, half wave rectifier, full wave rectifier. We don't know. Next logic gates I will take. Then transistor. They are saying removed part, but just try to understand. Okay. As in the next thing we will say the middle part of the benefit is. Okay. So revision should also be posted in the group. Or else we'll do optical instrument చెప్తాను లేకుండా optical instruments complete చేసి resolving for repetition అనుకోండి one part of entire optics అయిపోతుంది. So two laws. What are the two laws understood everyone? This is what Brewster's law. That is called analysis of polarized light when passing through other analyzer. I is equal to I naught cos squared is called Mahler's law. Okay, this is called Brewster's law. And what is polarized light or the unpolarized light? Definitions. What are polarized? What are property? Select to absorption technique called dichroism. Okay, this is more than sufficient for your syllabus. Other methods also there. Double refraction methods and Cbse. Okay, again we have ordinary ray, extraordinary ray, elliptically polarized light, plane polar, but that is not our syllabus. Only this is optical our syllabus. And one more is optically active substances under. So when you are passing this particular polarized light, no, so certain materials are optically active. Your dextrorotatory substances, leorotatory. In chemistry we have no isomerism. So what happens? No, the plane of polarization of this particular light is what rotated actually. When ordinary light passes through it, no, so what all possible vibrations are there. So when you are allowing for through a particular material is plane polarized light, the plane of vibration itself is what rotated. Such kind of materials which rotate the plane of polarization, there is clockwise, anti-clockwise, dextrorotatory substances, leorotatory substances. From this property as plane of polar rotate, no. So when they are passing this optic axis is like this, for example, that material is there. When you allow, so if the vibrations are like this, you won't get any kind of light. Okay, so vibrations are like this. Direction of propagation is in this way. So this kind of vibration, direction of propagation, what kind of nature it is? Transverse nature. Yes or no? So this is what completely what is happening here, rotated here. So by this property, what you could able to know that transverse or not. Okay, and such kind of materials which rotate the plane of vibration are called what? So optically active substances. Okay, optically what? Active substances. So rotatory or dextrorotatory, leorotatory substances we have. Okay, I will check the next class. I will continue. Fine. Yeah. Thank you all.